we're going to show you here we're going to do a log transformation. So the next chapter we'll do a log transformation. So here we've got a table of values shows lifespan in years and GDP, which I think is some growth whatever it is, you guys know, in 12 countries. So the association is non-linear and they want me to do a log X transformation. So let's go have a look at this data. So if I go back, we would put in our two lists. So we've got lifespan and then we had GDP, okay? And they said that the association is non-linear and they're putting lifespan is the Y value, okay? So it says write an equation in terms of variables, lifespan and that. It did say GDP is the EV, so you did get told this one is EV. So they want me to do an X, a log transformation on the X, which would be the GDP. But first, let's just briefly go over it. We would see a GDP, we'd see lifespan, and you can see it's very curved there. Can you see the curve? So if you went back on your transformation circle, back up here, it looks like this one, and you can see log X is one of the options. So we are doing a good one here. So go back here, we're going to do a log transformation. So maybe just write L for log and then GDP, so you know what you logged, yeah? And then you can find the list easier. Now we press equals in the one underneath and what you called it should come up. Now, to get the log function, boys, it's the same as what we were doing, but press control and that 10x button, which is next to the 1, and you'll get the log. Now, we always do log 10. Everything in our general maths is log 10. So we do that. Now move up into that little square, and that's where I have to tell it what we want to log, and it's GDP, and that should go dark because it should know that's the list you want, and you press enter. Now, if yours has an actual number, don't stress, all good. If yours says like mine does, log whatever, no stress, who cares, it doesn't matter, it's logging them. You don't need to worry as long as you've created that list. Now, we are going to go write the equation. So it said write the equation in terms of lifespan and that. So we're going to get the A and B values. So menu, stats, stat calc. Sorry, very trigger happy. Okay, we changed the X list. So I called it log GDP. But the Y list I didn't change, and what was it? Lifespan. And you click OK. So let's go. It says to write the equation to 3 significant figures. So we have that there. So sorry, I'm going back to here. Just in here, it says I'm going to write it underneath. Write the equation. So it's lifespan. And I might put the units. They did tell me up in the question. It was years, so I'm going to write lifespan in years equals. Now, 3 significant figures. I get 54.3 plus our 3 significance for our B value would be 5.59. And we're going to say times. I'm going to just double check that was correct, was it? Yep. What was it? Yeah, 3 significant figures. No. It should be 5 point, what should that be? Oh yeah, 59, that's okay. Yep, that's all good. Just double checking that. So it's times, now it's log, isn't it? Yeah? Log 10 of the GDP, sorry. Okay, so I'll just put that in subscript so you can see. Okay, so log 10 of GBP in dollars. Okay, so we've got the equation there. And then it says use the equation of the regression line to predict a lifespan for a country with a GDP of 20,000. So, once again, you would have to use this formula, but you will obviously put in 20,000 in the GDP spot. So you type that on your calculator, which I'll do in a minute. I'm just 59 times so 20,000 is going in there. Okay? And then, so if we do that on our calc, just on a normal calc page, let's do that. We get 54.3 plus 5.59 times, now we want to get the log function again, so log 10, and we want to put the 20,000 in there, and press enter, and I get 78.3. Does that look roughly right looking at your table of values? Yeah, so then you know you haven't hopefully stuffed it up. So 78.34. What did it say? We'll go 78.3 because it's talking about 3 significant figures.
You put dollars?
Yeah, no, lifespan, so it's years. You predicted their years. Okay. No, that's what we subbed in. So we subbed in GDP to find lifespan. Now, boys, if you get asked, if you've done a log Y transformation, just be careful when you're asked to predict. You must use the solve function to find your Y, and I'll do it on the next one, so that's okay. Sorry. So we can do it on our next one. All right. So we've done that one. Let's move to our next one, where we're going to do reciprocal. Okay, so it shows the length in centimetres and the width of 8 sticky labels. Okay, they want us to fit a regression line with length as the EV, but they want us to do a 1/y transformation. So we're going to do a Y transformation, and this is where it's good because when you predict when they're in the Y's, it's a little bit different. So let's have a look. So go to our listen spreadsheets, and we would type in length, and we'd put in our width. Okay, and they said length is the EV, so we want to do a reciprocal Y transformation. So what I type over here, I could put width because it's a reciprocal, and hopefully you get used to hearing that word, reciprocal. Now underneath we're going to write equals, and like what we do to get a fraction, so we just press control divide, we're going to have 1, and then when you write down the bottom, this is where we've got to put our list. So it's width, it should go dark, and then you press enter, and now you have that. So now we want to get the equation. So I'm going to go menu, stat calculation, a plus bx. The x list I did not change, which was length, but the y list is the reciprocal of width, width. Okay, click OK. Now it says, I'm going to say, let's get the equation to 3 significant figures. So for the A, it'll be 0.147, and for the B, it'll be 0.0859. Yeah? 3 significant figures. Okay, so let's go back and type that in here. I'll just type it underneath. So it would actually, when you write the equation, remember it's 1 over width. Okay, 1 over width equals 0.0147 is what we said. And then it was plus and it was 0.0859, wasn't it? Is that correct? Yeah. Yep. And then we're going to say times the length. Okay, so that's our formula. Now, it's set up here, so write in terms of length and width. We've done that, the new equation. Use the equation to predict the width of a sticky label of 5 centimetres. Be careful, this formula now is not a formula directly for width. It's a formula for 1 over width. So how we're going to get around that when we're predicting, so when we're making this prediction, when length equals 5, I think, what we're going to do is we're going to use our solve function, and we're going to type it in like this. We're going to use solve, and we're going to write the formula. Sorry, so you'll write solve, we'll have the formula, 1 over width, but I'm going to times it by 5. And what I'm going to do is I'm going to say comma W, because otherwise the formula will give you the reciprocal of width. We don't want that. We want the actual width. So you'll do that, comma W, and you should find, I'm just going to pop the answer there, that the width would equal, and we'll do it. Oh, actually, I'll do it over here. I'm not sure on my thing. So I'm going to do it on my calc. So how do we get the solve function? We haven't used this for a while. Menu 3.1, yeah. And I want to write a recip 1 over W. So do that fraction template exactly. Write exactly what you've got for your formula. So 0.0147. Was that correct? Plus 0.0. Oh, I can't remember what it was. What was it? 0.0859. Yeah? Times 5. And we've got to do comma W. So when you've done a Y transformation, we're going to use the solve function to predict. And we predict, and we get a width of 2.25. Which, does that make sense looking at our data? Does that look good? Yeah? If we look at the lengths, when there was a length of around 5, was it 2-ish? Yes? Yeah, so that looks good. So it's a length of 0.25. Okay. Let me stop this video.